The next item that we need to learn is the concept of linearity of differential equation. And by the way, I forgot to write it here. Linearity is specifically for ordinary differential equation. So if you're given with a partial differential equation and you're asked as to whether it's linear or not, then you can simply say not applicable because it's not possible for partial differential equations. Yes, we can classify ordinary differential equations as to either it's linear or not. When can we say that a certain equation is linear or not? The linearity or a linear ordinary differential equation is actually in the form a sub n, x times your variable x. You have here your nth order derivative of y with respect to x, so meaning your x is your independent variable, plus a n sub n minus 1, and still you will have another x here. So you have here the nth minus 1 order derivative of y with respect to your x. Then you have here plus until you will have a sub 1 x. So still you have your x here. So that's a sub 1. You have the first order derivative of y with respect to x. Then plus a sub 0 x and then y, would be equal to a certain, I cannot write the entire thing here. So let me compress this. A sub 0 x times y will be equal to g of x. Okay. So again, let me redo it. Sorry for this. Is equal to g of x. Okay. Now, I would like to bring you to three different things here to consider really that our ordinary differential equation is a linear one. The first one here is our independent variable, in this case x, because it appears here. Okay? Our independent variable x may be part of each term. Okay? So it could be part of every term, even the right hand side term, because this is expressed as g of x. It's a function of your x. Now, but your dependent variable, in this case y, should only be present at this portion here, and its exponent is actually 1. That's why it should be considered as linear. Okay, so if it appears on this term, okay, or this term here, then there is a possibility that our ordinary differential equation is non-linear. Okay, so next here is our g of x. The expression on our right hand side, as mentioned, should contain x in the form. But if it contains, say for example, if the right hand side is, say for example, if expressed as x plus y, of course you can move that y on the right hand side, and if it still satisfies the presence of y on this term here and its exponent is 1, it would still be linear. But what if it's y squared? Once you move that on the right hand side, you will have here y squared. It's no longer linear because the exponent of our y should be equal to 1. So again, if a differential equation, specifically an ordinary differential equation, would follow this form or can be transformed into this form, then that given ordinary differential equation is a linear ordinary differential equation. If it cannot be transformed in this form, then of course it's non-linear ordinary differential equation. We'll have more examples to this in determination whether an ordinary differential equation is a linear or not. Again, please be guided that this linearity is only for ordinary differential equation. Thank you very much for watching.